Hello everyone and welcome to my YouTube channel. Today again I'm going to look at a moment distribution question, and I'm also going to look at a frame. So the question reads, analyze the frame shown below by moment distribution method and sketch the bending moment diagram. If you look at this question, it has a cantilever, but span CD is a cantilever. It has also two joints, B and C. The moment of inertia of span AB, BC, and CD is 2I throughout. Span BD and span CF is I. The loading for A to C is a UDL of 2 kN per meter. The cantilever has a point load of 8 kN. BE, there's no loading. So let's go into the procedure of solving this question. So you have to be very careful this type of question because you have to balance two joints, that's joint B and joint C. So the first step is to calculate the fixed end moment. Step 1 is calculation of fixed end moments, and the sign convention that I've adopted is anti-clockwise moments are negative and clockwise moments are positive. So for MAB, I'm assuming there's an anti-clockwise moment here. The formula is WL squared, so it will be negative WL squared divided by 12, which is minus 2 times 5 squared divided by 12. And if you do that, you will get 2 times 5 squared divided by 12. You will get negative 4.17. So for BA, the answer now will be the same, except now the sign now will change to positive 4.17 kilonewton meter. So the next thing we're going to calculate is for BC. Again, the UDL is 2 kilonewton meter, so it will be negative 2. Now the span is 4 meter times 4 squared divided by 12. If you do that, 2 times 4 squared divided by 12, you get here now it will be negative 2.67 kilonewton meter if you leave your answer into 2 decimal place. Now for CB, the answer of course will be positive 2.67. Now for part CD, there is a cantilever and it will cause a rotation of a clockwise direction. So it will be now CD, it will be 8 times 3 and you will get 24 kilonewton meter. Now let's go to step number 2. And now is calculation of stiffness factors and distribution factors. So I've prepared a table like this. So we'll start with joint B. So BA, if you are standing at joint B, look at the diagram here, the far end A is pinned. So the stiffness factor formula is 3EI over L. 3EI over L because joint support A is pinned. So if you substitute the values, it will be 3 times 2 divided by 5. The span is 5 and you get 6 for 5 EI. For BE, it is fixed. Support E is fixed, so it will be 4 EI over L. So it will be 4 times 1 divided by 4, and you get basically 1 EI or just EI. For C, again C is also fixed, so the formula is 4 EI over L, so it is 4 times the moment of inertia of 2 divided by the span is 4, to get 2 EI over L. Now if you add all these, 6 over 5 is basically 1.2. So if you add 1.2 plus 1 plus 2, you get 4.2 EI. So eventually the EI will cancel out. So now to get the distribution factor, it's K over the summation of K. So for the first one, it will be 1.2 divided by 4.2, and you get it is 0.286 in 3 decimal points, that I'll encourage you to leave your answer into 4 decimal points to increase the accuracy. But to avoid writing so many numbers, I've used 3 decimal points for this question. So the next question will be now 1 divided by 4.2, which is 0. Sorry, I'll repeat that. So so I think I made a mistake here. This is supposed to be 0.238, and then for support BC it will be now 2 divided by 4.2, and you get now this one is 0.476. So those are the relative stiffness factors, that is 0.286, 0.238, and 0.476. Good. Now the next thing we are going to calculate now the stiffness factors for joint C. There are two members, that is CB and CF, both of which are fixed. If I can go back to the question here, you'll see CF is fixed and CB is also fixed. Good. So now the first one will be 4EI over L. 4EI over L. 4EI over L. So it will be 4 times 2 divided by 4, which is 2EI of L. The other one will be CF will be 4EI divided by L. So our span is 2, so it is 4 times 1 divided by 2, again 2EI. So the summation is 4EI. So the distribution here factor will be 2 divided by 4, which is 0.5, and this one 2 divided by 4, which is 0.5. Good. So the next step now is to calculate to do the moment distribution, and for that I've prepared another table here. So you have the joint or the supports. You have support A, E, and F. Remember, CD is a cantilever, so we are going to include it here. So we have member AB, the distribution factor is 1. BA is what we have calculated, 0.286. BC is what we have calculated here. BC is 0.476, and BE is 0.238. So now the others for EB also, the distribution factor for a fixed end is 0. CB is 0.5. CD is a cantilever, it is 0. CF is 0.5, and FC is 0. So the next thing you write is the fixed end moment, the ones we calculated in our very first step. For AB is 4.17, for BA is negative 4.17, BC is 2.67, BE, we said there was no loading, so it is 0. Same case with EB. For CB, it is negative 2.67. For CD, the cantilever is 24. CF, there is no loading, is 0. And of course, FC also, there is no loading. There's no loading, it is 0. If you look at this diagram, here there's no loading, and also here there's no loading. There's no loading in these two members. So now Next, now we are going to calculate. Before we start distribution, remember end support A is pinned, so we need to release it. Support A is pinned. If you look at our question, support A is pinned, so we need to release it by applying an equal and opposite moment. So you add negative 4.17 and you do a carryover. So half of this now comes here as a carryover of negative 2.09. So now the new moments, this will be 0, of course, we have released it. The new moment now it will be negative 4.17 plus negative 2.09. You get 6.26. 4.17 plus 2.09. You get negative 6.26. Next thing you this one there's no change here. Also here there's no change. Everywhere else there's no change. So now let's start now our first distribution. So the out of balance moment in joint B. In joint B, this is B. This is C. This is C. This is B. Sorry. So it's a summation of all these three moments. This one, and this one, this one. So it's negative 6.26. Negative 6.26 plus 2.67, of course, plus 0, and you get the out of balance moment is negative 3.59. So this is the out of balance moment, and this is the moment that we need to balance according to the distribution factors. So the balancing moment will be the opposite sign. If the out of balance moment is negative, the balancing moment will be positive. So it is 3.59. The balancing moment will be 3.59. So it will be 3.59 now times the distribution factors. The first one is 0.286, and you get the answer is 1.026. So I'm using 3 decimal places, so it will be 1.03. So the next will be 0.476, and you get it is 1.708. So in 3 decimal place, it will be 1.71. It will be 1.71. So the other one, BE, it will be now 2.38. Sorry. So you get 0.854. So 0.854, if you like, or yeah. So the next thing now you do is to do the carry over for joint B. So half of BC goes to CB. So 1.71 divided by 2, you get 0.86, and half of this comes here as 0.43. Now let's now turn our attention to joint C. So what will be the unbalanced moment? The unbalanced moment will be the summation of this one, this one, this one, and this one. So it will be negative 2.67 plus 24 plus 0.86. So 22.19. So this is the unbalanced moment. So the balancing moment will be negative 22.19. Negative 22.19. So negative 22.19. Now we are going to use the distribution factors of 0.5, 0, and 0.5. So if you apply the distribution factors times 0.5, so this one will be, it is 11.09. So into 2 decimal places, this is negative 11.10, and negative 11.10. So the next thing you do now is to do the carryover. So half of CB comes to BC as negative 5.55, and half of this CF goes to FC, which is fixed as negative 5.55. Again, now let's turn our attention to joint B. So this is the only out of balance moment here. So the balancing moment will be 5.55. So 5.55 again times now the distribution factors 0.286, and you get 1.59 into 2 decimal place. Then for BC it will be 476, you get 2.64, and finally BE 1.32. I believe this is 1.32. So again, you do the carryover. So half of CB goes to BC as 1.32. Then half of this comes to half of BE goes to EP as 0.66. Now let's turn our attention to joint C. So this is the out of balance moment for joint C. So, and the distribution factor is half and half. So if the out of balance moment is positive, the balancing moment will be negative. So the balancing moment here will be negative 1.32 times a half, which now you get negative 0.66, and this one negative 0.66. Again, you do now the carryover. So half of CF comes to FC as negative 0.33. Again, half of CB goes to BC as negative 0.33. Now let's again turn our attention to joint B. So this is now the out of balance moment, negative 0.33. So the balancing moment will be positive. Again is 0.33, that is the balance moment, times 0.286. Always remember, if the out of balance moment is positive, the balancing moment will be negative. If the out of balance moment is negative, the balancing moment will be positive. So I see a lot of students confuse that, so don't forget the sign, it's very important. So the first one for BA, it will be 0.09. This one I've calculated here. For BC, you get 0.15. If you round off, I've rounded off here to 0.16, but it is important to use at least 4 decimal place. Then the last one, you will get, again rounded off to 0.08. Then the next thing you do again is do the carryover. So half of BC goes to CB here as 0.08. Again, half of this comes here as 0.04. So now the last distribution I'm going to do is for C. So this is the out of balance moment. So the balancing moment will be negative 0.08. So negative 0.08 times the distribution factors of 0.5 and 0.5, you get negative 0.04, and here's 0.04. So the question will tell you how many distribution you need to do, but if it doesn't, if you start getting 0.0 something, you know you are now converging towards a more accurate answer. So for me, I'm going to leave my distribution up to there. And now to get the final moments is basically an addition. So this one is already 0. It's a a pin support. So the next thing, when you add all this value, negative 6.26 plus this plus this plus this, and if your math is correct, you should get negative 3.55. So let me do that quickly. Negative 6.26 plus 1.03 plus 1.59 plus 0.09, and you get negative 3.55. So you do the same, you add all these values in this column, all these values. If you are accurate, you'll get 1.30. Again, you add all this from this line here going down, you get 2.24. Again, you add all this, you get 1.13. Again, if you add all this, you get negative 12.21. And if you add all this, oh, sorry, this is supposed to be 24. Sorry, 24. If you add all this, this will be 24. If you add all this, you will get negative 11.80, and if you add all this, you'll get 5.88. So please subscribe to this channel, share this video, helps someone to help someone. Thank you for watching, and see you next.